All right, so in this exercise, we're going to try to think about some of the experimental weaknesses that exist in this simple calorimeter setup, which is similar to the setup that you'll be using in your experiments in our class. And to really understand them, it's helpful maybe to compare with something called the bomb calorimeter, which we don't have, but we can still look at a diagram of a bomb calorimeter to see this is a setup that essentially is going to maximize efficiency and minimize any sort of experimental weakness. So this will give us essentially the most accurate specific energy values possible. So just to explain the diagram here, you can see that on the inside there is it says sample dish. So you can imagine that your sample dish is where your fuel is. So the fuel is in here. There are wires that are called ignition wires because when ready, they can send an electric current in here, which will cause the fuel to combust. You can also see there's an oxygen inlet. So this machine is connected to a tank of oxygen, which will supply a lot of oxygen gas. That's really important for combustion. And you can see that the container with the fuel and the oxygen where the burning is happening is surrounded by a container of water, which is being constantly stirred. That's where the temperature is being measured. And then surrounding that, there is insulation all surrounding the water. So that's the setup. Now I want you to think about what are three key weaknesses with the setup on the left, and try to think through why that will lead to inaccuracy in a specific energy value, and how you think it will affect the experimental value for a specific energy. Will it make it lower? Will it make it higher? And why?